Hi everyone, so we're going to look at the continuation solution for higher order differential equation, particularly the second order differential equation. Now in today's topic, we're looking at boundary value problem. So a boundary value problem is a problem in which one is to find an unknown function fx, function yx that satisfy both a given ODE and a given boundary condition y0 equals to 0 and y1 equals to 0. The boundary condition normally is useful when solving higher order differential equation. Okay, so typically boundary value problem looks like this. Okay, what's the difference between BVP and IVP? Okay, so these are the difference. Okay, so for IVP, initial value problem, for instance, you have the same equation, the second derivative plus dy dx plus y equals to 0, and you are given one initial condition. Okay, you're given one initial condition. Now BVP, boundary value problem, look at this condition here. You are given a boundary for x from 0 to x equals to 1. Okay, so you have two conditions. I mean, initial condition can have two conditions, but the x is the same. Okay, for boundary value condition, your x is different. You have different x values here. Okay, so we can say you have a boundary value problem. Okay, so if you have now moving on to homogeneous equation. So what is homogeneous equation? So if this is your differential equation, look at this gx here. Homogeneous, if gx equals to 0 and if gx not equals to 0, it's said to be non-homogeneous. So for instance, we have here my gx equals to 0. By comparison, so I have a homogeneous equation. Now this is my gx. My gx is not equals to 0, so I have a non-homogeneous equation. Okay, now we're going to make some important assumption to solve this second order differential equation. For the rest of the notes, the following assumptions are made. The coefficient function are continuous, and an x not equals to 0. What does mean? So the assumption are unique solution exists. Okay, that's what we want to make so that we can able to solve the differential equation. Okay, let's move on to differential operators D and L. In calculus, differentiation is often denoted by the capital letter D. That is, dy dx equals to dy. The symbol D is called the differential operator because it transforms a differential function into another function. So for instance, okay, this one. What does mean? It means you differentiate this. Differentiate this one will give you minus 4 sine for x. Differentiate. The D is a differential operator, gives you differentiation of this, which is 15x to minus 12x. Okay, if you have higher order, the notation for differential equation, so this is my dy, this is my d. Okay, so we can write d dy, d squared y. Okay, so for the second derivative, we have d2y. Okay, so now why this differential operator important? Let's look on. If we have an nth order differential operator, okay, let's say we have a polynomial given as this. Okay, the differential operator L possesses a linearity property, that is L operating on a linear combination of two differential functions. is the same as the linear combination of L operating on individual functions. So this linear operator is important to find the solution. So this is my operator here. Okay, so L operator, so alpha fx plus beta gx. So I can, by the linearity property, I can write this as this. Okay, any linear differential equation can be expressed in terms of D notation. Okay, any linear differential equation, say linear, okay, linear, not non-linear, linear. For example, this one, I can write in terms of D notation. So this is d squared y minus 5 dy plus 6y equals to 5x minus 9, or something like that. Okay, you can write them. So remember, my dy dx equals to dy. Okay, that's my y prime is dy. Okay, so we have superposition principle. The superposition principle say that the sum or the superposition of two or more solution of an homogeneous linear differential equation is also to be a solution. So the superposition principle say that let y1, y2, yk be solution of an homogeneous nth order differential equation on interval I. The linear combination y equals to c1 y1x plus c2 y2x plus ck ykx, where ci equals to 1, 2, 3 and k are arbitrary constant, is also the solution of the interval. So what does superposition principle means? It means that if you can write the solution in this form, we have to write in terms of a linear combination. Okay, so let's say for k equals to 2, for k equals to 2, we have the differential operator L and y1x and y2x be the solution. So we have the linear combination of y1, y2, c1 and c2. Okay, so we write like Ly equals to the linear combination of this one, c1 y1x plus c2 y2 x, which I can write as by the L operator. I can write as c1 ly1, okay, L I can bring it inside here, c2 ly2. Okay, so this one here, c1, this product 0 plus c2 0 equals to 0, okay, because of this. Okay, so this is the superposition principle. So meaning the superposition principle is true if I let c1 y1x plus c2 y2x equals to 0. Okay, example. Okay, show that y1x squared and y2x squared ln x are both solution of the homogeneous linear equation. Okay, are both solution. Okay, so can we write this in terms of the operator? So I want to write this as c1 y1 plus c2 y2 equals to 0. c1 is the constant here, y1 is my x squared plus c2 x2 ln x equals to 0. So this is my y. Okay, now what is y prime? Y prime is 2x c1 plus, you need to use a product rule here. I'm going to write it up here. So if u equals to x squared, v equals to ln x, so we have u prime, which is 2x, and v prime equals to 1 over x. So we have c2 u v prime plus v u prime 2x equals to 0. Okay, let's simplify this. Y prime equals to 2x c1. Y prime equals to 2x c1 plus c2 x squared 1 over x plus c2 x squared 1 over x plus ln x 2x. I think it is correct. Plus ln x 2x equals to 0. Okay, now I gotta simplify this first before finding y double prime. So I have 2x c1 plus c2 cancels out this x plus 2x ln x. Okay, now finding the second derivative gives me 2c1 plus c2 1 plus, okay, let's assume this is my u, this is my v, u dv dx plus v du dx. Okay, so now simplifying this gives me 2c1 plus c2 cancels out x here, 1 plus 2 plus 2 ln x. Okay, so simplifying again, 2c1 plus 3 plus 2 ln x c2. Okay, now what do I do here? You want to find whether the solution says show that these are both solutions of the homogeneous linear equation. So we gotta put it into this equation here, x3 y triple prime. Oh, I have to find y triple prime too. So finding y triple prime, this is 0, 2 ln x c2 will give me 2 over x c2 now. Okay, so we are given this equation. We are given this equation here. x3 y, the third derivative minus 2xy prime plus 4y. So we have x3y, third derivative minus 2xy prime. Make sure you don't write it wrong. Plus 4y equals to 0. So plus 4y equals to 0. So substitute x3. Now my third derivative is this one. 2 over x c2 minus 2x, and y prime is this whole thing here. 2x c1 plus c2x plus 2x ln x c2. Now don't forget plus with 4y. So what is my y? The one that I've written as a superposition principle, c1 x2 plus c2 x2 ln x. Okay, now let's see if we can get it 0. So negative 4x c1 plus this one, this is 0. Okay, negative 2x to c2, which cancels out with this one. This gives you 0 to 2x plus 2x, 4x ln x c2 will give me 4x squared. Okay, so we can manage to get this is equals to 0. So by getting 0, it means that we have showed that y1 x2 and y2 ln x are both solution of the homogeneous linear equation. Now if you want to do it quickly, all you have to do is you have to differentiate these two into this equation. Okay, that's all for today. The next topic that we're going to look at is do this exercise and then we will try to look at more